Tax 2017 Project 3, design and develop a fixturing system to hold the parts in position. But please do not use the fixturing system simply because CRA does not consider as fixture development as the pure R&D. As we are going to go through these photos later, you will see this is not really a simple fixture, whereas in fact it was a machine. It was a device to hold all these components together while the robotic arm was performed in fabrication. So that device has to be able to hold position various chair components. There are devices are out there, or simple fixture are out there, that are able to hold only one type fixture at a time while the machine or operator does the fabrication. But there is no machine out there which is able to basically hold a series of different products at the same time. The key was developing a fixturing system or a device to hold various chair sizes, anywhere from 20 inches to 22, 24 inches, low back, high back, with the various features including ganging or locking mechanism, backrest, and cup holder. All this should be done using only one device. As you are developing it, at the same time, while meet under 30 seconds cycle time. This is the equipment as you see, or device as you can see. To make this one, there was a series of problems involved. One of the biggest problems that they had was a safety issue. The parts were moving during the location, and they failed to develop a proper alignment. As you can see, this is a part didn't meet the proper alignment, and the operator, they could not put their hands into the machines, and due to safety reasons. So they had to develop a technique to somehow the parts automatically is going to get proper alignment. To solve that one, I'm going to zoom in so you can get a better picture. They use, after doing an extensive investigation, to use magnetic system. There is one magnet here, two magnet. As soon as these parts, there are three magnets, 1, 2, and there is another one right on top there. As soon as the part placed into the machine, the magnetic got activated and aligned the parts. Next was to bring these clamping arms, 1, 2, and third one on top, to lock a part in position. The key was that is, as the initial prototype that they had, as the clamp came down to hold the parts, the clamp caused the upper part get dislocated by at least half an inch to 3/4 of an inch. So this misalignment was a major problem, and they were not sure how to solving it, while at the same time not interfering with placing and removal process. As you can see, one of the major problems they had, aside from these components of the chair, you can see the machine has so many moving parts in it. So limited space, so many moving parts, they had to make it work. To make it work, going back to what I said earlier, they had to do extensive investigation and redesign. This clamp that you see located over here, these two clamps, and the magnetic has to be in that position. If it was a lower spot, which initially they had it, and the bracket was further up, it caused the whole component get this position as soon as the clamp was activated. This is for the ganging or locking mechanism, as somehow they had to hold this bracket in position while the robotic comes and apply the welding. The problem that they had, the conventional clamping system didn't work. That head that you see over here, they had to do extensive experiment with various head design to finally come out with this U-shape profile. The initial sample that they had a flat head that applied force only on top of the bracket, which was unable to firmly locate it. And it caused the part to slightly, roughly about 1/8 or 1/4 inch to move to the left and right, or something get completely shifted, fail having a proper alignment with the frame. Other design that they had a flat head. The flat head also didn't work because it was interfering with the jig below it. Finally, they came out with the tooth shape, U shape, which was able to hold the parts in place. Another problem that they had, this is the strip. The strip doesn't matter how much you pass it through the straightener, they get some variation. As you can see, it's not perfect straight. This variation caused that when you place it into the machine, doesn't get a proper alignment. To solve that, since they couldn't solve the problem, making it straight, always there was some variation in it. So what they decided to do, they developed a shoe, a custom shoe. And the shoe was grooved with a flat bottom, so it's going to get nice and tight connection. Here we go. As you can see, this is perfectly aligned. This is one step. Second step was this cylinder, you can see, comes at the back. The arm was a major design. Roughly, as you can see, the arm is twisted by 22, and the head was, you don't see on the picture, but it's a round. It's not that 90 degrees straight. It's round, allowing it as it turns coming down to hold it in position. A, does not interfere with the part. Second, hold the parts exactly in the position. So they had to make it 2 units. This is 1 unit on this side, another unit on the other side, in order to hold the parts in position during the fabrication. And they introduced electromagnetic in order to hold the parts in position while the arms come down and lock it. As again, there are so many components go into making a chair. One major problem that they had is, this is the chair. At the bottom of the chair is a book rack. And this book rack has a fixed spacing between them. This spacing cannot be altered. It's roughly about 1 3/4. As you can see, the spacing of the hole on a strip has to add between these 2 wires. Otherwise, the robotic arm cannot come and apply this to a screw. This is in a good position, whereas the second one, as you can see, is almost the wire is interfering with the screwing. If it is done manually, operator can do it, whereas robotic arm cannot do it. The screw has to be perfectly at the center of these 2 wires. That was a major problem as they were designing the device. To solve that one, right now I'm not sure if you can see. Let me zoom in so you can clearly see. This is almost a finished unit. As you can see, there are 2 cylinder units. These cylinder units initially came all the way down to the bottom. So whole this was 1 unit, second was whole unit. But they realized that as they're having that unit, they were not able to maintain the proper alignment for the screw. To do that one, they came back, they had to redesign the machine in a way that be able to maintain a spacing. Let me go back to explain what do I mean by spacing. This is the spacing here from the end, from this frame that you see, from the end to this screw is always a fixed space. You cannot increase this space. If the space if the space is increased, say for example, if the hole, these two holes are placed over here, it causes the whole backing to flex and get deformed, which is not trying to do. So